Okay, we've got another problem, another special relativity problem here. And this one, I must say, is a little tricky, so listen closely and follow along. What we've got is, here we've got the planet Earth, and here we have a space traveler in his, of course, what else? Rocket. And the space traveler in the rocket, at the point when he embarks on his journey, he is 25 years old. And on Earth, the year is 2010. Now, this space traveler is on a long journey. He travels away, and he's traveling at a velocity of 2.75 times 10 to the power of 8 meters per second. That's approximately, by the way, almost 91 to 92% the speed of light. Now, way later, in the year 2040, so 30 years later, the astronaut comes back to Earth. He shows up and he says hi to this guy standing on Earth. He says, "How are you doing?" Of course, you see, this guy on Earth, let's just say he was a classmate. They were classmates, and let's say this guy was 25 years old too when his friend left. Let's say they were both the same age when he left. Well, it turns out that when he gets back, if it's now 2040, how old will this guy be? Well, that's a pretty simple calculation. 2010 to 2040 is a difference of 30 years, and if he was initially 25 years old, then obviously he's going to be 25 plus 30, so he's going to be 55 years old. But his friend that went on the trip doesn't look 55 years old. He looks younger. And so this guy standing on Earth, who's been on Earth now for the last 30 years, says, "Wow, you look younger than me." And he says, "But you've been gone for 30 years. But this guy the space traveler responds by saying, "No, I haven't. I haven't been gone for 30 years. I've only been gone for..." Now, what does he say? That's what we have to find out. We have to find out when he gets back how old is the space traveler. Now, in order to figure this out, we have to figure out, it's kind of like a two-part question, because in order to figure out how old he is, we have to figure out how long he was gone. How long gone? Once we can figure out how long he was gone, then we can add that to his age when he left, and that's how old he'll say he was. So this is kind of a tricky problem, and we need to step back here. Obviously, there's two variables. One is t and one is t naught. And we know the equation states t equals t naught. Those are the two variables, and we know the equation too. The difficulty in solving this type of a problem is figuring out what is what here. First of all, let's ask ourselves a simple question, okay? What's being measured, and who's doing the measuring? First of all, let's ask ourselves this. You see this elapsed time of 30 years? This actually looks, there we go, that's a better 3. This 30 years, who has done this measurement? this is the person who has done the 30-year measurement. And what is he measuring? He is measuring the time that this person is away. Okay, I'll repeat that, okay, because that's a really significant point. This is the person who's doing the measuring, and he's actually measuring, this is what he's measuring. How long is his friend gone? Now, knowing that, ask yourself this. He's measuring how long this guy is gone, but now this guy is in a different frame of reference than he is, isn't he? He's measuring the time that's passing of this guy, but he's measuring it from his own reference frame. So what he actually measured this 30 years is he's measured t. Okay? So now what we want to find out is we want to find t naught. And you see, t naught would be the time that the traveler would say, yeah, I was gone that long. Because what is he measuring? He's measuring how long he was gone. And what's he measuring? He's measuring now something in his own reference frame. He's measuring his absence, the time of his absence. But he's doing it himself, so he's measuring t naught. So let's figure out this by taking this equation and manipulating it and solving for t naught. So t naught is equal to t times 1 minus v squared over c squared. And now let's put it in. So this is t is 30, right? 1 minus v is 2.75 times 10 to the power of 8, all that squared, divided by 3 times 10 to the power of 8, which is the speed of light, squared. And what are we going to get? Well, let's get our trusty RPN calculator. Here we go. 1 enter 2.75 EE8 squared, 3 EE8 squared, divided by, subtract, square root 30 times. And we get an answer of approximately, well, it's 11.9, but we're just going to round it to 12 years. Now, what does that mean? That means if you ask the traveler says he's been gone for 12 years. How old does he look now at this point? Well, he was 25 years old when he left, and he says, the traveler himself says, well, I've been gone for 12 years. That would make him, right? 25 plus 12, well, that would make him 37 years old. So now the traveler comes back to Earth. He's 37, but his friend is 55. What you are now seeing an example of is time travel. You see, because his friend is 55, he should on all accounts be 55, but he's not. He's actually 37. So in effect, he's 18 years into, he's jumped, the difference of 37 to 55 is 18 years. So in some sense, the traveler has jumped 18 years into the future. But don't forget, there is a price that he has to pay in order to accomplish this. Obviously, the biggest, most difficult task is traveling at that speed. But secondly, how long did he actually spend traveling? If you ask him, he spent 12 years traveling. So he has to travel, according to his own clock, for 12 years at that speed. And by doing so, he will have jumped 18 years into the future. Because now when he gets back, instead of his friend being 37 like himself, his friend is 55 years old. And everybody else also is 18 years older than they should be. So there you go. Hope you enjoyed this problem. It was a real tricky one. Thanks for watching.